Hi all, welcome to Week 4's post-tutorial video. In this video, I'll do a quick recap on Chapter 2 using multiple choice questions. Let's get started. So let's have a look at the first question over here. Choose the highest energy involved when an electron makes a transition. So what do you need to know? What you need to recall from our class is that I told you when an electron drops from a high energy level to a low energy level, if the gap is larger, that means the energy will be higher. So in this case, it will be from n equals to 3 to n equals to 1. Alright, so if you compare the others from n equals to 2 to n equals to 1, and n equals to 4 to n equals to 2, and finally from n equals to 4 to n equals to 3, you will realize that n equals to 3 to n equals to 1 has got the highest energy. Alright, so let's move on to the next question. The next question is determine the number of electron in copper atom. They have given you the configuration over here. At its ground state, if the azimuthal quantum number, which is L, equals to 0. So we all know if L value equals to 0, it is referring to the s orbital. Thus, how many s orbitals we have? 1, 2, 3, and 4. So if we calculate the total number of electrons, okay, that would give us 7. Alright, so question number 3. So question number 3 here, we are required to calculate the wavelength, okay, the wavelength for the fourth line in Balmer series. So the fourth line in Balmer series, n final would be n equals to 2, the first line would be 3 to 2, second line would be 4 to 2, third line would be 5 to 2, and the fourth line would be from n6 to n equals to 2. And what formula do we have to use? So 1 over lambda equals to Rydberg constant multiplied by 1 over n1 squared minus 1 over n2 squared, whereby n1 must be smaller than n2. So please remember to use the correct value of Rydberg constant, which would be 1.097 times 10 to the power of 7 meter. Okay, all right. Next question. Let's look at question number 4. So which of the following represents 3p orbital? So yeah, we have to first check what is the principal quantum number. N value would be 3. So all the options over here has got an n value 3. Next, we look at the azimuthal quantum number, which is also the angular momentum quantum number, which is p equals to 1 value. Thus, option A and B is not correct, as well as option D. So there you have it, option C. Next. So the electrons are filled according to the following order. So which order is correct? For this, you should have remembered the Aufbau principle. Okay, and as you can see, option 1 is correct. We are just here to test you that 4s comes before 3d. Alright, so the next question over here, we have gallium, and gallium has got an electron configuration of this. Now what happens when we want to form gallium 3+? We have to remove 3 electrons. And how do we remove it? We remove from the highest energy orbital first, followed by the next. So highest energy orbital would be 4p, so there's 1 electron. And then we remove both the electrons in the 4s, giving us gallium 3+. Alright, next question. So which of the following does not obey Pauli's exclusion principle? So what do we have here? Pauli's exclusion principle says that no 2 electrons can have all 4 same quantum number. And since C option, as you can see it clearly, 2 electrons are spinning upwards, so that does not obey Pauli's exclusion principle. Next, how do we arrange 8 electrons in a 3d orbital? So our focus here is on a 3d orbital. So we have 5 platforms and 8 electrons. First, we have to use the Hund's rule, and next we have to use the Pauli's exclusion principle. It's not Aufbau's principle because we are only focusing on one orbital over here. Alright, and the next question is, what are the possible magnetic quantum number? Magnetic quantum number is your M value when an atomic orbital has got N5 and L4 value. So N5 and L4, who determines the M value? It's actually the L value. Since the L value is 4, therefore we know the M value will start from -4 to 0 to +4. And that would give us option 2 and 3. Alright, and the last question is a bit of the next chapters, but never mind, we can always discuss it. We have an electron configuration of element Z. Okay, which of the following configurations are true? So is the element in D block? So no, we are going to learn it this week in week 5. We have to look at the valence electron configuration. Valence electron configuration is the one with the highest principal quantum number. And the last electron, as you can see here, it's entering the p orbital. Therefore, it should be from the p block. I'll explain this more this week. And next, as you can see, what ion does it form? It has got a valence electron of 7. Alright, because as I told you, the highest principal quantum numbers, the configuration would be our valence electron configuration. So the number of valence electron would be 7, and we all know from SPM, if you have 7 valence electron, you are going to accept 1, and that would make your ion a singly negative ion. And finally, the element is in period 4 of the periodic table. Yes, because as you can see, the highest principal quantum number here is 4, so that refers to the period. Okay, so a little bit of teaser for what is coming up in week 5. That's all for this video. Thank you.